Note when working with the argument for a complex number. One must be careful when working out the argument. For z equals a plus bi, we cannot simply use theta is the inverse tangent of b over a, as the period of the tangent function is pi, and the calculation above will always return theta in the range negative pi by 2 to pi by 2, or if you're in degrees, that's negative 90 up to 90. In other words, we'll always get an angle returned that's on this side of our diagram, but our complex number might be over here. So it's always best to sketch to make sure we get the correct angle, which we did see in the last example. But let's just take an example here. Let's say we've got Z1 is equal to, let's go for 2 minus 4i. And let's have a Z2, which is, say, negative 3 minus 4i. Now, if we look at a quick sketch here, so we'll go re and im. Our Z1 is at 2 minus 4i, so it would be, say, down here. So this would be Z1. And our Z2 is negative 3, take 4i, so that's probably somewhere around here, say. And the arguments that we want, well, this would be the argument for Z1, and this angle here would be the argument for Z2. Now let's bring in the calculator and just do the inverse tangent of negative 4 divided by 2. And let's just put it in degrees because it's easier for us to recognize angles there. And that would give me negative 63.43. So this one is in the right position. So negative 63.43 or 63.43 degrees below the real axis. That's in the correct position for Z1. But if I do the inverse tangent of negative 4 over negative 3, looking at Z2, that gives me 53.13, which is obviously an angle that is up here. But my sketch tells me that this is actually the 53.13, and that what I need to do is go from negative 180 degrees, I need to go forward 53.13. So that one would be negative 180, add the last answer, and that would be at negative 126. And we can see that this angle is in the right position then.